In example 1, we're going to go through and talk about just some terminology, some background information about angles before we move forward. From geometry, you may recall an angle being defined as two non-collinear rays that share a common endpoint, known as the vertex. An angle can also be thought of as being formed by the action of rotating a ray about its endpoint. What we're going to be doing in this chapter is dealing a lot with forming angles on our coordinate system. So with that, we have an initial side, a terminal side, and what we call standard position. Standard position means that the angle is going to be positioned so that its vertex is at the origin. Our initial side is always going to be at the positive direction of the x-axis. So this right here is what we would call the initial side. And then where it ends, this is just going to be a straight line. This is our terminal side. So there's our angle of rotation. Here's the vertex. So this is side 1, the initial side. As we rotate it, wherever it stops, this side right here is the terminal side. We also are going to be dealing with positive and negative angles. So if we think about positive angles are going to be rotating counterclockwise. So it's going to start here, and then it's going to rotate in this direction. This is going to be a positive rotation, so it's counterclockwise. Our negative angles are going to rotate clockwise. So we are going to start in the same spot in this positive direction of the x-axis. And then if we come here to that terminal side, we are now rotating this way, which is going to be a negative rotation, a negative angle. And again, negative angles go clockwise. Underneath that, it says measuring angles in degrees is useful to solve many real-world problems, such as those in surveying and navigation. For other applications with trig functions, using an angle in degrees poses a significant problem. A degree has no relationship to any linear measure. Measuring angles in radians provides a solution to this problem. The measure theta in radians of a central angle of a circle is equal to the ratio of the length of the intercepted arc S to the radius r of the circle. So that tells us that theta, if you take a look at this picture right here, if we have this angle of rotation, theta is going to be equal to S, the arc length, divided by the radian, or the radius measure. And there's just an example here if you want to read through it. Then if we get to the next part, it says the central angle representing one full rotation counterclockwise about a vertex corresponding to an arc length equivalent to the circumference of the circle, which is 2 pi r. So the circumference of a circle is 2 pi r. From this, you can obtain the following radian measures. So this is the part that you really want to understand and know. So if we have one full rotation about our circle, that means we're taking 2 pi r, the circumference of our circle, and dividing it by r. And that's going to give us 2 pi radians. So what this is saying is that one full rotation about our circle is equal to 2 pi. So if we draw a little picture, here's the middle, that's our initial side, and what we're doing is we're rotating all the way around, and that rotation all the way around is equal to 2 pi. If we do half of a rotation, then we're taking 1/2 of our full rotation, which is 2 pi. So 1/2 times 2 pi, which tells us that half of a rotation is just the length of pi radians. And if we think about that, here's our center, here's our initial side, and what we're doing is we're rotating halfway around. And that rotation of halfway around is equal to pi in terms of radians, 180 degrees if we're thinking of degrees. A quarter of a rotation means that we're taking a quarter or a fourth of the initial 2 pi rotation, which would give us pi over 2 radians. So if we think about the picture, here's our center, there's our initial side, and what we're doing is we're going just a quarter of the way around, which would be straight up to there. And that's going to be our pi over 2. which would be similar in terms of degrees. You're thinking 90 degrees, a quarter of the way around. And then the other one we'll be dealing with quite a bit is a 1/6 of a rotation. So we'd take 1/6 times our 2 pi, and that's going to give us pi over 3 radians. So if this is our center, here's our initial side, we're going to go about 1/6 of the way, which is here, and that's going to be when theta is pi over 3. These are just some common ones that we're going to see and use quite a bit as we get through the chapter. Underneath that it says, because 2 pi radians and 360 degrees both correspond to 1 complete revolution, you can write 360 degrees is equal to 2 pi radians, or 180 degrees is equal to pi radians. So again, we've got 2 pi and 360 degrees is the same all the way around. Halfway around is 180 degrees or pi, and we talked about these as well. Therefore, we can say that 1 degrees is equal to pi over 180 radians, and 1 radian is equal to 180 over pi degrees. And we're going to use this information to be able to do some conversions. To convert a degree measure to radians, so degree to radians, we are going to multiply by pi radians over 180 degrees. And then to convert a radian measure to degrees, we're going to multiply by 180 degrees over pi radians. And we'll see that coming up in example 2.